Welcome to Understand the Math. In this Calculus 1 video, we're tackling one of the most fundamental ideas in all of calculus, derivatives and rates of change. We're going to explore slopes of secant and tangent lines, learn how to write the equation of a tangent line, look at average and instantaneous velocity, and then learn the formal definition of the derivative. We'll walk through lots of examples so you can see how each concept works in practice. Be sure to download the free guided notes to help you follow along step by step. We're going to start by looking at the slope of a secant line and the slope of a tangent line. A secant line is just a line that intersects a curve at two or more points. Down on our graph, we have a secant line drawn here in purple, and it intersects our curve at points P and Q. A tangent line is just a line that touches a curve at a single point. Down here in red, we have a tangent line, and it touches the curve at point P. The slope of the secant line through points P and Q is defined as the change in f, which up here in our graph is f of x minus f of a, all divided by the change in x, which is x minus a. The slope of a tangent line at x is equal to a is defined in two ways. The first way is it's defined as the limit as x up here on our graph approaches a, of delta f divided by delta x, the same one that we used for the secant line, or it's defined another way as the slope of the tangent line is the limit as h approaches 0, where h is just the distance between x and a. So as x approaches a, h is going to approach 0, where delta f up here in the upper right is f of a plus h minus f of a, and then delta x is just h. Let's look at some examples where we're going to find the slope of a secant line and slope of a tangent line. In our first example, we're going to find the slope of the secant line to the curve y is equal to 4x minus x squared through the points P, located at 1, f of 1, and Q, located at some point x, f of x. I've graphed this function so that we can see what the secant line looks like before we go and find its slope. This blue point here is point P, and then I put a point Q to the right of P and another point Q to the left of P. Our secant line then between P and Q looks like this, or looks like this. Let's now find its slope. The formula for the slope of a secant line is m sub sec is equal to f of x minus f of a, all divided by x minus a. Now let's go ahead and we're going to plug in that f of x is 4x minus x squared, and a is the x value where our point P is located, and that is at 1. We now have the slope of the secant line is f of x, which is 4x minus x squared, minus, we have to put parentheses here because we have to subtract off both pieces, f at a, which is 4 times 1 minus 1 squared. And we're going to divide all of that by x minus a, which is now x minus 1. Let's now simplify our algebra. This is 4x minus x squared minus, inside the parenthesis here, we have 4 minus 1, so that is 3. And we divide this by x minus 1. Let's rewrite this so that we have our highest power of x first, and we get minus x squared plus 4x minus 3, all divided by x minus 1. And that's our answer the slope of the secant line through points P, located at x is equal to 1, and point Q, located at an arbitrary point x. Let's now look at our second example. In this example, we are going to find the slope of the tangent line to the curve y is equal to 4x minus x squared. This is the same curve that we saw in our previous example at the point 1, 3. Let's begin by writing down the formula for the slope of our tangent line. The slope of our tangent line is just the limit as x goes to a of the slope of our secant line, which is f of x minus f of a, all divided by x minus a. We're now going to substitute in that f of x is 4x minus x squared, and a is the x value of the point where we want to find the slope, and that's equal to 1. The slope of our tangent line is then the limit as x approaches 1 of f of x, which is 4x minus x squared, minus f of 1, which is going to be 4 minus 1. We just substitute in that x is equal to 1, and then we're going to divide all of this by x minus a, which is x minus 1. Let's now simplify the numerator. This is 4x minus x squared minus 3, and we have an x minus 1 in the denominator. Looking at the numerator, we can see that we can factor it, but I think it'll be easier to factor it if we first pull out a negative. So I'm going to go ahead and do that. This is the limit as x goes to 1 of minus x squared minus 4x plus 3. See how already that looks like it's going to be easier to factor? All divided by x minus 1. Now let's go ahead and factor our numerator. This is minus x minus 1, x minus 3, all divided by x minus 1. This is nice. You can see that the x minus 1 terms are going to cancel, and we can go ahead and substitute in that x is going to 1. So this is a minus 1 minus 3. So that's minus a negative 2, and we get a value of 2. This tells us that the slope of our tangent line is equal to 2. Up here on the right, I have graphed our function, and you can see that we found the slope of this tangent line at the point x is equal to 1, and you can see that the graph agrees with our answer because that line has a slope of 2. We're now going to find the equation of a tangent line to a curve using the limit definition of the slope of a tangent line. Our curve is given as y is equal to f of x, and we're going to find the equation of this tangent line at the point P, which is defined to be x1, y1. The formula for the equation of a tangent line to a curve is given as y minus y1 is the slope of the tangent line times x minus x1. That's a really great formula to memorize. When we find the equation of a tangent line, most of our time is going to be spent in actually finding the slope of the tangent line, and that slope using a limit definition can be defined in two ways. In the example that we're going to do, we're going to use both of these formulas so that you can see how they both work. It really depends on what your function is as to whether one is easier than the other. In this example, we are going to find the equation of the tangent line to the curve y is equal to x minus x cubed at the point 2 minus 6. Let's begin by writing down the formula for the equation of our tangent line. That is y minus y1 is equal to the slope of our tangent line times x minus x1. Let's now find the slope of the tangent line using our first definition. That definition is the slope of the tangent line is the limit as x approaches a of f of x minus f of a, all divided by x minus a. We're going to be substituting in that f of x is x minus x cubed, and then a is the x value of the point where we're finding the tangent line, and that is equal to 2. Let's go ahead and substitute this in. This is now the limit as x goes to 2 of f of x, which is x minus x cubed, minus f of a, which is 2 minus 2 cubed, all divided by x minus a, which is x minus 2. Let's now work on the numerator and clean it up. I'm going to write this as minus x cubed plus x, and then let's do this. Let's calculate what this is, and then we'll plug it in. This is 2 minus 8, which is minus 6. So we have a minus 6, so that gives us a plus 6, all divided by x minus 2. Now, this is where it gets complicated. We have to factor our numerator, and it's a cubic. The best way to do this is to use long division or synthetic division. I have a video on both of those if you need to review that. I am going to use synthetic division just because I think it's easier. When we use synthetic division, what we do is we take our denominator and we're going to set that equal to 0. So we're going to take x minus 2, set that equal to 0, and we get x is equal to 2. Now we're going to take a little box like this and we're going to put the 2 up here. Now we're going to have to put the coefficients of the x's in this polynomial right here. So our first coefficient is minus 1, and then we don't have an x squared, so we have a 0 in front of the x squared, and then we have a 1 in front of our x, and then we have a 6. Then you draw a line, you put a little arrow here because we're going to pull that number down. Now what we're going to do is multiply this number times this number, which is going to be minus 2, and we're going to put it here. Now we're going to add 0 and minus 2, which gives us minus 2. Now we're going to multiply 2 times minus 2, and we get minus 4. Now we add 1 and minus 4, get minus 3. We're almost done. We're going to multiply 2 times minus 3, and we get minus 6, and that is 0. So this tells us that we have minus x squared minus 2x minus 3. We can now put that up into our limit, and we have the limit as x goes to 2 of minus x squared minus 2x minus 3. Now we're home free. We can go ahead and just plug in x is equal to 2. So we have a minus 2 squared minus 2 times 2 minus 3. Let's see what this gives us. This is minus 4 minus 4 minus 3, and this is equal to minus 11. So our answer for the slope of our tangent line is minus 11. Before we plug this value into our equation for the tangent line, I want to show you how to find the slope of the tangent line using another definition. The second definition looks like this. Slope of the tangent line is equal to the limit as h goes to 0 of f of a plus h minus f of a, all divided by h. A lot of textbooks and instructors will have you actually compute the slope like this 2 different ways just to get practice. Let's remind ourselves that our f of x is equal to x minus x cubed, and then our a is equal to 2. Let's go ahead and plug this in. This is the limit as h goes to 0 of f of 2 plus h minus f of 2, all divided by h. I think it's really important when you do problems like this to not do too many steps at once. Now what we're going to do is find f of 2 plus h. Wherever we have an x, we are going to plug in 2 plus h. This gives us 2 plus h minus 2 plus h quantity cubed minus, now wherever we have an x, we're going to plug in 2. So this is 2 minus 2 cubed. And then all of this is divided by h. Let's go ahead and simplify our numerator. This is the limit as h goes to 0. We have 2 plus h minus 2 plus h quantity cubed minus, let's see what this is. This is 2 minus 8, which is minus 6. So we actually have minus a negative 6, so this is plus 6. And we still have h in our denominator. The hard part of using this formula now is we have to calculate this cubic. Let me go ahead and write down the formula for a cubic in case you don't know it. This is a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's now plug that in. This is the limit as h goes to 0. I'm going to go ahead and combine the 2 and the 6. So this is going to be 8 plus h minus, here we go. This is a cubed, which is 2 cubed, plus 3 times 2 squared times h, plus 3 times 2 times h squared plus h cubed, all divided by h. Now let's go ahead and let's simplify. This is the limit as h goes to 0, 8 plus h minus 2 cubed, which is 8, minus 3 times 2 squared, so that's 3 times 4, which is 12. So we have minus 12h, minus 6h squared, minus h cubed, all divided by h. I always tell students you never really get good at algebra until you take calculus, and then you do lots of algebra and eventually get good at it. Let's see here. Our 8s can cancel, and that's about it. So let's go ahead and let's combine some terms. We have the limit, h goes to 0. We are going to combine the h and the minus 12h. So this is minus 11h minus 6h squared minus h cubed. Hang with me, we're almost done. And we're going to divide this by h. We have an h common to all the terms in our numerator, so I am going to pull out an h, and we're left with minus 11 minus 6h minus h squared. We divide all of this by h. And then the nice thing is our h's cancel. And we can go ahead and now substitute in the h is equal to 0. So here's our h. We are going to set those terms equal to 0, and we end up with an answer of minus 11. And you can see that that agrees with what we got when we used the other formula. In the first formula, we ended up having to use synthetic division, and then in the second formula, we ended up using a cubic. Now we're all set to go ahead and find the equation of our tangent line. Let's write down our formula again. It's y minus y1 is the slope of our tangent line times x minus x1. And the slope of our tangent line, we just computed to be minus 11, and our point x1, y1 was the point 2 minus 6. This gives us y minus y1, which is minus 6. We have to be careful with the negative there. The slope of the tangent line is minus 11, and we have x minus 2. This is y plus 6 is equal to minus 11, x plus 22. I'm going to pull the 6 to the right-hand side and write our answer as y is equal to minus 11x plus 22 minus 6. So we have y is minus 11x plus 16. And that is the equation of our tangent line. We're now going to learn how to find average and instantaneous velocities. Average velocity is the total displacement of an object divided by the total time elapsed. I've written down our formula for average velocity. It's notated as v sub av. It's actually the slope of a secant line, and it's the change in position, because s is position, divided by the change in time, where t is time, and it's given as s of t plus h minus s of t, where h is the total time elapsed or the time interval, all divided by h. Instantaneous velocity is the velocity of an object at a single point in time. It is the limit of the average velocity as the time interval approaches 0. Our formula for instantaneous velocity is just written as v, and it's actually the slope of a tangent line, and it's the limit as h approaches 0 of our average velocity given by this formula. We're now going to look at an example where we need to use this formula. Suppose a rock is launched vertically upward from the ground with a speed of 96 feet per second. Neglecting air resistance, the position of the rock is given by s is equal to minus 16t squared plus 96t, and we're asked to find the velocity when t is equal to 1. Let's begin by writing down our formula. Our velocity is the limit as h approaches 0 of s of t plus h minus s of t, all divided by h. Now we're going to substitute in what s is. S of t plus h is going to be minus 16, and then up in our formula, wherever we have a t, we're going to substitute in t plus h. So this is minus 16 t plus h quantity squared plus 96 t plus h minus s of t, which is minus 16 t squared plus 96 t. And we're going to divide all of this by h. Now we just have to do a lot of algebra. I'm going to start by multiplying this out. This becomes minus 16. T plus h quantity squared is t squared plus 2th plus h squared. And then we have a 96t plus 96h. Now we distribute our negative to these terms, and we have a plus 16t squared minus 96t. And then all of this is divided by h. Now what I'm going to do is I'm going to take our first term and multiply through minus 16. This is minus 16t squared minus 32th minus 16h squared. And I just realized before we go ahead and write everything else down, I see two terms that cancel. This term and that term cancel. So let's cancel them and not have to write them down again. So what's left is 96h plus 16t squared. And then again, we have h in our denominator. Now let's look up and let's see if other things cancel. This term is going to cancel with this term, and then nothing else cancels. However, if you look at these three terms, notice that they have an h common to them. So we're going to go ahead and let's pull that out. So we have the limit as h goes to 0 of h minus 32t minus 16h plus 96. And all this gets divided by h. We can cancel an h from the numerator and the denominator. And now we can go ahead and just substitute in that h is going to go to 0. So we have minus 32t plus 96. That is our formula for the velocity. Our problem asked us to find the velocity when t is equal to 1. So all we have to do is we take v, substitute t is equal to 1, and we can get our answer. So this is minus 32 times 1 plus 96, and that is 64. And we are doing a word problem, which means we have to have units. Our speed that we were given was in terms of feet per second, so our velocity will be in terms of feet per second. So let's write down feet per second. And that is our final answer. We're going to now learn how a derivative is defined and walk through some examples. Limits arise when we calculate things like the slope of a tangent line or a rate of change such as velocity. I've written these definitions here so you can see that their definitions involve limits. Can you see that these limits look really similar? Since this limit occurs widely, it is given a special name and notation. This limit is called the derivative of a function at a number a. There are two definitions for this derivative, so I've written the first one in pink and the second one in purple. The derivative of a function at a number a is defined as the instantaneous rate of change of the function f of x at the point x is equal to a. It is also defined as the slope of the tangent line to the graph of f at the point x is equal to a. I've placed a graph down here so that you can see where these limit definitions come from. Let's first look at the definition in pink. It is the limit as h goes to 0 of the change in f, which is f of a plus h minus f of a, divided by the change in x, which is h. Our definition in purple is the limit as x approaches a of delta f, which is f of x minus f of a, all divided by delta x, which is x minus a. We're going to look at some examples where we'll find the derivative of a function at a number a using the definition of the derivative. In our first example, using the definition of the derivative, we are going to find the derivative of the function f of x is equal to 3x squared minus 4x plus 1 at the number a. There are two limit definitions of the derivative that we can choose, and I'm going to choose the one that has the h in the denominator. This is f prime at a is equal to the limit as h goes to 0 of f of a plus h minus f of a, all divided by h. Now we're going to substitute in. Wherever we have an x, we're going to plug in a plus h. This is 3a plus h squared minus 4a plus h plus 1 minus our function f of a, and wherever we have an x, we're going to plug in a. So this is 3a squared minus 4a plus 1. And we divide all of this by h. Now we have to do some algebra and multiply some things out. This gives us the limit as h goes to 0. I'm going to multiply this out first. So we have 3. This is a squared plus 2ah plus h squared. Now let's do some simplification. This is minus 4a minus 4h plus 1. And then we have minus 3a squared plus 4a minus 1. And all of this gets divided by h. I want to show you before we go on the most common mistake I see students make when they do a calculation like this. It's this part right here. You have to remember that this negative gets distributed to all three of those terms. Now all we have to do is multiply things out. This is the limit as h goes to 0, 3a squared plus 6ah plus 3h squared. And now before we go ahead and copy down all those terms again, let's see if anything cancels. Do you see that the minus 4a cancels with the 4a and the 1 cancels with the 1? Now we don't have to write those down again. And all we have to write down is minus 4h minus 3a squared. And then we have our h in our denominator. Let's again look and see what cancels. This term cancels with this term, and nothing else cancels, but notice these three terms. Do you see that they all have an h common to them? Because of that, we can go ahead and we can pull an h out. So this is the limit as h goes to 0 of h. We have a 6a plus 3h minus 4, all divided by h. Now our h's cancel, and we can go ahead and just substitute in that h is equal to 0, and this gives us an answer of 6a minus 4. And that is the derivative of our function at the number a. Let's now look at another example. Whenever I used to give this example on a quiz or a test, it was usually the most missed problem. I want to make sure that you understand how to do this. The following limit represents the derivative of some function f at some number a. We are asked to find f and find a. The way you want to begin a problem like this is to write down the definition of the derivative that corresponds to the limit that you're given. In part A, our limit is going to correspond to this definition of the derivative. F prime at a is the limit as h goes to 0 of f of a plus h minus f at a, all divided by h. Now what we're going to do is we are going to compare our formula to the limit that we are given. Our f of a plus h is equal to the square root of 9 plus h. Let's write that down. F of a plus h is the square root of 9 plus h, and then f of a is equal to 3. With this information, we can find out what f and a are equal to. A plus h is equal to 9 plus h. So this tells us that a is equal to 9, and then f at a plus h is equal to the square root of a plus h. We want to know what f of x is. To find f of x, wherever we see an a plus h, we're going to substitute in x. So f of x is just the square root of x. Now, this problem has a really nice built-in check, and that built-in check uses the other piece of information that we haven't used yet. F of a is equal to 3. So let's just go down here to our function and say that f of a is equal to f at 9, which is the square root of 9, which is 3, and that agrees. So we know we've done the problem right. Let's look at part B. This limit is similar to this definition of the derivative. F prime at a is the limit as x goes to a of f of x minus f of a, all divided by x minus a. Now let's go ahead and let's equate things. F of x is going to be x to the 6th. So we write down f of x is x to the 6th, and then f of a is 64. To find a, all we need to do is compare our limits. X goes to a is the same as x goes to 2, so that tells us that a is equal to 2. So we found that f of x was x to the 6th and a was equal to 2. And here's our built-in check. We're told that f of a is equal to 64. Let's see if that's true. F of a is f at 2, which is 2 to the 6th, which is indeed 64. So we know we've done the problem right. And that's it. You've now seen how derivatives naturally arise from slopes of secant and tangent lines, how to find the equation of a tangent line, how to interpret velocity as a derivative, and how to use the formal definition of the derivative. To really master these concepts, make sure you work through plenty of practice problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.